Hello everyone, my name is Victoria Alexeyeva. I'm from Kharkiv National Medical University, and today I would like to tell you about automatic creation of masks for marking microscopic images of the epithelium or the paranasal sinuses. The results of the study in many sectors of medicine are based on the detailed study of images. Moreover, the correct assessment of the received data often depends on a large number of indicators. The need to evaluate medical images today is one of the priority tasks in radiology, pathomorphology, dentistry, otolaryngology, and many other medical specialties. Such an assessment and interpretation of the results are most often carried out in a manual mode. According to everything was mentioned above, the aim of our work was to propose software solution which made it possible to radically reduce the time of creation masks for image and analyze the shortcomings of the automated creation of masks as well as the directions of their solution. To improve the aim of our studies, materials and methods were chosen. For the correct training of the neural network, it was necessary to organize its correct training. One of the ways of learning is to select an object in the image by using mask of marking arrays. Image annotation is one of the main tasks in computer vision technology and consequently in the development of artificial intelligence elements. The study involved 25 male and female subjects who were distributed by sex and age according to the recommendations of World Health Organization. The specimens, as it can be seen from figure 1, were stained with hematoxylin and eosin after the routine procedure. The microscopic study was performed on an Olympus BX41 microscope with subsequent processing by Olympus DP soft version 3.2 software. Morphometric studies were performed in the dome of osteometal complex, which was chosen for morphological interpretation. The image processing and mask creation method can be represented as a sequence of the following steps. First step was a determination of the preliminary characteristics of the image, such as resolution and color palette. The second one was setting of the conditions for matching of a pixel to a mask. Third one, iterating over all pixels of the image. Fourth one, if the pixel meets the specified conditions, then it belongs to the mask, otherwise it is excluded from consideration. The diagram of the algorithm for creation an image mask, which is present in the figure 2, shows the algorithm of the software tool. However, the block "does the pixel meet the condition" needs further clarification. Based on these characteristics of the task and the images that form the data set, restrictions are imposed on the values that are red, green, or blue channels parameter can take. Results of our work are present in figure 3. You can see the result of obtaining an image mask for training a neural network. First part of the figure shows us original image. Second part shows an image which was labeled by a specialist. And finally, the last part shows resulting masks. Figure 4 shows the process of compiling an image mask for training a neural network using the developed software tool. With A, you can see the original image. With B, you can see image which was labeled by a specialist. And C, you can see a resulting mask. Figure 5 shows the process of compiling an image mask for training a neural network using a developed software tool with a modernized algorithm. With A, you can see the original image. With B, you can see an image which was labeled by a specialist. And C, you can see the resulting mask. These masks were made for 25 images. The result for various methods of obtaining image mask is shown in the figure 6. With A, you can see mask which was made manually. With B, you can see mask which was made with help of software. And C, mask made with the help of software during the upgrade. Table 1 summarizes the result of the masking process study. Column 1 indicates the method for obtaining masks. Two programs were taken that are usually used to create masks, the developed software and its modernization. The second column displays the total time it took to create masks for 25 images. The time was given in minutes. Column 3 provides an average time spent processing one image, time given in minutes. Column 4 is the share of the reference value, is given in persons. The result of work with label me is taken as the reference. It is in the first position, clearly showing the savings in the time and resources. Column 5 is the average discrepancy between the masks. The masks are compared pixel by pixel, and in case of the mismatch, such pixel is taken into account as a discrepancy pixel, then the total number of discrepancy pixels is divided by the total number of image pixels. However, if we correlate that in manual mode one image is processed for about 5 hours, and for software taking into account manual adjustment of the color palette, it was 3-5 minutes. Given that there was no interface and we have no make changes directly to the code, if the interface is improved, then the loss of time due to the adjustment of the color palette can be reduced even up to 1 or 2 minutes. The average deviation is 7.61%. And in the figure 7 you can see different versions of masks divergence. With A, you can see mask which was made using the software, and B, the mask was applied manually. And you can see that some parts of cells were missed in the second image. So, in the conclusions, I would like to say that in the course of our study, a basic algorithm was developed and put into practice for automatically creation masks for marking microscopic images of the epithelium of the paranasal sinuses. This method is distinguished by its information content and accuracy. it can be greatly reduce the time it takes to process medical images. Thank you for your attention.